Module 6.2, Angles and Trigonometric Functions. This is 5.1 and 5.2 in your book. 6.2 opener. In this section we're going to study trigonometry. We're actually going to start looking at trig functions, and we're going to look at the properties of triangles to begin with. So it's going to be very important for you to focus on how we define trig functions. The definition is very important. And it can always be thought of visually, so make sure that you practice drawing the triangles. Remember, all of this is about triangles. Degree measure. We're going to define an angle measure starting at some point. We're going to look at a ray starting at some point we call the initial point, and then extending from there to some other size, some other point called the terminal point. Right? We can have a dot there, or usually we put an arrow there. Okay, so we're going to start with a ray, and then we're going to imagine that ray moving counterclockwise to some other position, right, where the terminal side has moved, the initial side hasn't moved. And we're going to call this little inside part right there the angle measure. Measure. You have to be careful. Usually what we call the angle is these arrows right here. The arrows is what we refer to as the angle. And this inside part is what we call the angle measure. But sometimes we call that part the angle just because we don't want to say angle measure. Okay. A common way of measuring angles is degree measure. If a ray makes one complete rotation, so if you take one ray and go all the way around to the same point, that's defined to be 360 degrees. And I'm going to go kind of fast. You can always pause the video later, but this is a long section, so I'll be going a little fast. So 360 degrees is all the way around. If we want to know what 1 degree is, all we have to do is take 1 out of 360. Right? 1 degree would be 1/360th of all the way around. Likewise, if we want to figure out what 90 degrees is, all we do is divide it by 360 degrees. 90 divided by 360 is 1/4. So, and usually you want to start with the ray being horizontal, just because a lot of things are standardized like this. So 1/4 of the way around would just be about right there, right? And that's what we call a 90-degree angle measure. We usually, instead of using a circle, a little semicircle there, half circle, to measure that, we put a quarter of a box there to denote that's 90 degrees. Okay. Another 90 degrees would be 180. Another 90 degrees would be a total of 270. 180 degrees. And another 90 degrees would be, again, 360 degrees. An acute angle is an angle that's measure has to be between 0 and 90 degrees. So between 0 degrees and 90 degrees. An obtuse angle is an angle that's greater than 90 degrees, bigger than 90 degrees. So acute is between 0 and 90, obtuse is bigger than 90. So here's an example of something that's less than 90, something like 60 degrees. An angle that would be bigger than 90 would have to be bigger than that, so something like this, let's say 110 degrees. Acute, obtuse. Right angles are exactly 90 degrees. That's what we call a right angle. And usually to denote these angles, we use the Greek letter theta. It's a circle with a horizontal line through it. That's our usual notation for an angle. Theta. Complementary, supplementary angles. Complementary and supplementary angles are angles that add up to 90 degrees and 180 degrees. So if we have two angles, A plus B, and they're equal 90 degrees, they are complementary. If we have two angles, A plus B, and they equal 180 degrees, they are supplementary. Find the complementary and supplementary angles of 30. So we're going to look at this visually here. Let's say that's 90 degrees, so 30 would be right there. We know that 30 plus something else, we're going to use two dashed lines to represent a different angle. One dashed line for this angle, two dashed lines for a different angle. 30 plus what would give you 90? 30 plus 60. So that's one way of doing it, is imagining it visually. What about the supplementary angles? We could do the same thing. Supplementary angle would be, there's 30 degrees. And you have to ask yourself, well, what will get me all the way around to 180? What would get me to 180? Or we can do it algebraically. We can say, well, A plus 30 degrees is equal to 180. And I can subtract 30. And that would tell you that this angle has to be 150 degrees. So a complementary angle would be 60. A supplementary angle would be 150. And you could do it algebraically or geometrically. Same thing, find the complementary and supplementary angles of 60 degrees. Well, 60 degrees plus 30 degrees is 90, right? So that's the complementary angle. What's the supplementary angle of 60 degrees? There's 60 degrees. What would get me all the way to 180? 120 degrees. So that's the supplementary angle. All right, let's look at some algebra problems here. Let's say we had an angle of, let's say 3x here, at an angle of 6x here. And it's in degrees. Find x. And let's say this is a right angle here. This is a total of 90 degrees. Well, we know 6x plus 3x has to equal 90 degrees. In other words, 9x has to equal 90 degrees. In other words, x has to equal, when you divide both sides by 9, it has to equal 10 degrees. So 3 times 10, 6 times 10, still the same numbers as before. What if we had something like 4x here, and here we had a total of 6x? And this is 180 degrees in total, 180 degrees. Well, we know 6x plus 4x equals 180. Or 10x is equal to 180. So x has to equal, if you divide both sides by 10, 18 degrees. A minute is defined to be a 1/60th of a degree. And we use 1 with a minute symbol to represent the minute. 1 second is defined to be 1/60th of a minute. So a minute is a 60th of a degree, a second is a 60th of a minute, and is labeled 1 with the second symbol. So what that tells us is that 1 second is equal to 1/60th of a minute, which is 1/3600th of a degree. That's what you get when you divide this by 60 again, or multiply the denominator by 60. So we're going to use the technology to compute degree, minute, second calculations. What would be 5.53 degrees if we wanted to convert that to degrees, minutes, and seconds? So we don't want to just talk about degrees, but we want to have degrees, minutes, and seconds. Well, Alright, so we're going to type in 5.53. Notice if I go to mode real quick, if I go to mode, we need to be in degrees. So let's scroll down to where it says radians and degrees, and we'll talk about radians later. We're going to scroll over to degrees, hit enter, then second, quit. So we have 5.53, and we're going to go to second angle here. There's a degree symbol there, we're going to use that. So 5.53 degrees, and again we're going to go to second angle. And there's a little button right there that converts, number 4 there, converts to degrees, minutes, and seconds. So we're going to hit enter. So this is 5 degrees, 31 minutes, 48 seconds. 5:31:48. So 5 degrees, 31 minutes, 48 seconds. Remember, be in the right mode. If you're working with degrees, be in degree mode. Always check that from now on. The standard position of an angle on the coordinate axis. So now we're going to go back to the coordinate axis, the x and the y axis. A standard position is where we put the initial side on right at the center and the terminal side on the x-axis. That's the standard position. And from there we work the same way, right? We're going to move the ray a little bit. And then we say that this angle is in standard position. In standard position. Because it starts on the x-axis. Quadrantal angles, or angles that are multiples of 90. So all the ones we looked at before, from 0 to 90 degrees, from 0 to 180, from 0 to 270, and all the way around 360. We divide these quadrants, or we divide the x and y axis into quadrants, which we call quadrant 1, quadrant 2, quadrant 3, and finally quadrant 4, in the counterclockwise direction. Just so it's easier to talk about. Coterminal angles Coterminal angles are just angles that are multiples of 360. So for example, one of the angles we were looking at was an angle of 30 degrees. An angle that's coterminal to that would be adding 360. So from there, if I add 360, if I go all the way around back to the same place, so plus 360 degrees would give me, all from the very beginning, is 30 plus 360 would give me 390 degrees. These are coterminal angles because they end up in the same place. 30 degrees and 390 degrees are in the same place. They're almost the same angle. Likewise, if I add another 360 plus 360, that would just get me back to the same place, to the same angle. And I can also subtract. I could have said 30 minus 360 degrees, which would be negative 330. That would have been 30 in the other direction, minus 360 would have given me negative 330. And the negative just means you're going in the other direction. That's what coterminal angles are. Find the angle of least positive measure, of the smallest angle that's positive, that is coterminal with each of these angles. Let's start with theta is equal to, let's say, 795 degrees. We know that's more than one way around, because 360 is all the way around, right? So 795 has to be more, right? How much more? Well, we can figure that out. we're going to use the calculator. We're going to subtract 360. So we're going to take 795 minus 360 is 435. That's still bigger than 360, so we're going to subtract 360 again. It's 75 degrees. So what that tells us is 75 degrees plus 360 plus 360 is 795. So 75 degrees is our coterminal angle. In other words, instead of 75 degrees is a little less than 90 degrees. So let's say that's right there. It tells us that 795 would have gone all the way around from there twice, once, and then another time, but ended up at the same place anyways. Trigonometric functions. Alright, this is where we start with the functions now. Start with an angle theta in standard position at any point xy. So angle theta, there's theta, and any point xy. So here we're going to call this point x comma y, or p, it's fine too. And it's on the terminal side of theta, so that just means at the very end, like I have it drawn. And we're going to look at a right triangle formed by the line segment and the x-axis. So we're going to look at a vertical line segment right there that touches the x-axis and that forms a triangle. And a right triangle, because this angle over here is 90 degrees. And we're going to use the distance formula to find the length of the line segment. In other words, this line right here. That is, we're calling this height y because that's the y coordinate, and this width here x because that's the x coordinate of that point. And we want to find this value right here, which we can just call r. The distance formula says that r squared, or the Pythagorean theorem actually says that r squared is equal to y squared plus x squared. In other words, r is equal to plus or minus the square root of y squared plus x squared. But we know that that distance has to be positive, so we're not going to put plus or minus, we're just going to use the positive part. We define 6 trigonometric functions as follows. Now that we have that definition for a right triangle, we're going to define sine theta. I'm going to draw that triangle here again. R, Y, X, theta, and R is equal to x squared plus y squared square root. Sine theta is going to be the side opposite of the angle. Sine theta is going to be y over r. In other words, the side opposite of the angle. Y over r is sine theta. Cosine theta is the other one, x over r. And tangent theta will be y over x. And then we have other trig functions we're going to define. Cosecant theta is related to sine theta. It's r over y, the other way around. Secant theta is related to cosine theta. It's r over x. And cotangent theta is related to tangent theta. It's x over y. So for example, if I have an angle that corresponds to the point 3, 4, in other words, x value of 3 y value of 4. If this point is 3, 4. Then how can I find sine theta, cosine theta, and tangent theta? Well, I need to find r. Remember, r is 3 squared plus 4 squared, x squared plus y squared. So 9 plus 16, or 25. The square root of 25 is 5. So r is 5. And now all I need to do is remember what sine theta is. Sine theta is y over r, or 4 over 5. Cosine theta is x over r, or 3 over 5. Tangent theta is y over x, or 4 over 3. Likewise, find the sine, cosine, and tangent if we have a point that corresponds to negative 4, 1, 2, 3, 4, positive 5, 1, 2, 3, 4, 5. So there's the triangle we're looking at. This is a length of 4, but we're going to use negative 4, and 5 there. We need to find r. R is equal to the square root of negative 4 squared plus 5 squared, or 16 plus 25, which is 41. The square root of 41. So sine theta is y, or 5, over square root of 41. Cosine theta, and remember, r is always going to be positive, by the way. It's never going to be negative. Always positive. Always. Cosine theta is negative 4 over square root of 41. Even though this length right here is positive 4, we're still using the coordinate, the x coordinate of negative 4. Okay, that tells us that we're in quadrant 2 instead of quadrant 1, for example. Tangent theta is just y over x, so 5 over negative 4. When we're looking at quadrantal angles, it is sometimes easier just to work with something that has a radius of 1, or r, when r is equal to 1. So for 90 degrees, we're going to imagine that this angle right here, theta, corresponds to something that has a radius, or r, of 1. There's 90 degrees, and the highest can go is 1. So that means that x value has to be 0, because we haven't moved anywhere on the x side, and 1 for the y value, because we have at most a height of 1. Because r is 1, the highest that can be is 1. So now sine theta is y value, this is x and y, 1 over r value, which is 1. Cosine theta is x value, 0 over 1, the r value. And tangent theta is y value over the x value, 1 over 0. 1 over 1 is 1, 0 over 1 is 0, and 1 over 0, well, it has no value, it's undefined. We can't divide by 0. Find the values of sine, tangent, and cosecant for the angle formed by the point negative 6, 0. So now we're at negative 6 for the x-axis, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and 0 for the y value. So again, sine theta, again, I'm going to label this negative 6, 0, x, y. And what is our r, by the way? What is that length? R is equal to positive 6. Why? Because r is equal to the square root of x squared, or negative 6 squared, plus y squared, or 0 squared, which is equal to 36 plus 0. Square root of 36 is 6. Sine theta is 0 over r, or 0 over 6, which is 0. Cosine theta is -6/6, which is -1. Tangent theta is equal to 0/-1, which is 0. Reciprocal identities. From the definitions of sine, cosecant, cosine, cosecant, and tangent, cotangent, you should notice that sine is just 1/cosecant. Cosine is 1/secant. They're just reciprocals of each other. You just flip either fraction around. And tangent, theta, is equal to 1/cotangent. Alright, so given that sine theta is a half and cosine theta is equal to the square root of 3/2, find the value for tangent and cosecant. Well, this shouldn't be too bad because tangent theta is just maybe I should draw this out. It's not so difficult, but I'll draw it out. Sine theta is 1/2. That means that if you have some angle, some triangle, this side opposite of theta would be 1. In other words, the y part of it would be 1, and the x part, the r part would be 2, 1/2. Same thing for cosecant theta. This should be square root of 3/2. So everything matches up. Anyways, tangent theta is y/x, so 1/3. Cosecant theta is the reciprocal of this. It's not 1/2, but 2/1, or 2. Given that sine theta is square root of 3/2 and cosine is 1/2, find the values of tangent and cosecant. So now the other way around. And I'm going to form a triangle. Sine theta is square root of 3/2. Cosecant theta is 1/2. So tangent now is y/x, square root of 3/1, or square root of 3. Cosecant theta is the reciprocal of square root of 3/2, 2 square roots of 3. And you should always simplify these fractions if they have radicals on the bottom. Remember how to do that? 2/3 is called rationalizing the denominator. You multiply by the square root of 3 on the bottom, and you multiply by the square root of 3 on the top. That gives us 2 square roots of 3, and now the bottom cancels over 3. So you always multiply by whatever radical you have in the bottom. You do that to the bottom and to the top. Determine the sine of the trig functions given the angles. So if I gave you that angle is equal to 170 degrees, what would be the sine of theta? Not the value, but what should it come out to be, negative or positive? Negative or positive? What about cosine theta? Negative or positive? What about tangent theta? Negative or positive? Well, 170 degrees is not quite all the way up to 180. It's a little bit under 180. There we go. So again, we have to look at the x and the y values there. The x is negative. This is negative value here, and the y is positive. It's positive here. So sine should be, and the r is always positive itself. The radius is always positive. Sine theta should be positive over positive, so it's going to be positive. Cosine theta should be negative over positive, so it'll be negative. And tangent is positive over negative, so it's going to come out to be negative. A quick way of memorizing this is the mnemonic, all students take calculus, which says that in the first quadrant, all of the trig functions, right, sine, cosine, and tangent are positive, all of them. In the second quadrant, only sine is positive. Sine, cosine, tangent, only sine is positive. In the third quadrant, only tangent is positive. Sine, cosine, tangent, only tangent. And in the fourth quadrant, only cosine. Out of sine, cosine, and tangent, only cosine is positive. So all students take calculus, counterclockwise direction. All of them are positive. Sine is positive, tangent is positive, cosine is positive. The range of the trig functions. It's always going to be true that sine of any angle, it doesn't matter what you put in there, has to be between -1 and 1. Because we're looking at the ratios of the triangles, it's forced to be between -1 and 1. Same thing for cosine. The values for cosine are between -1 and 1. And tangent can be any value. Right, so if you see something like sine of theta is equal to 4.5, that's not possible, right? Because it has to be a bit less than 1. Sine of theta being equal to 0.9, that's possible, because that's less than 1. But 4.5 is not. Tangent 420, that's fine. That's possible. Any number is possible for tangent. So, okay, so suppose that theta is in quadrant 2. So I'm going to draw this out already. In quadrant 2, there's theta. And sine of theta is 1/3. So let's say that's our triangle, and we have 1/3 for sine theta. Y over r. Find cosine theta, tangent theta, and cosecant theta. We've already done some problems like this, so I'm just going to write the answer down. Okay, this should be square root of 8 over 3. This should be 3 over the square root of 8. Sorry, this should be not that. That should be 1 over the square root of 8. Cosecant theta should be 3. And you should also rationalize this, right, and simplify the top here. The top simplifies to be the square root of 4 times 2. The square root of 4 is 2. So this is the same in the bottom here, 1 over 2 square roots of 2. But we still have to rationalize the bottom, so we have to multiply by the square root of 2. Which would give us square root of 2 over 4. Some very important identities. These are very important. We get this from the Pythagorean theorem, because in a triangle we get that x squared plus y squared is equal to r squared. X squared plus y squared is equal to r squared. Right, we can divide everything by r squared, which is what we did here. In the next step, we divided the entire equation by r squared and wrote it as x over r squared plus y over r squared is equal to 1. Remember that cosine is x over r, sine is y over r, so we can just write cosine theta squared plus sine theta squared is equal to 1. And that's one of the identities. This thing is always true. Likewise, we have that tangent theta squared plus 1 is equal to secant theta squared. And be careful, we don't read this, we don't read these things as secant squared theta. We say secant theta, and that's what we're squaring. So if you were to type it into your calculator, you would have to put in secant theta in parentheses and then square it. There's no way of doing it this way. Likewise, 1 plus cotangent theta squared has to equal cosecant theta squared. Right? And also, because tangent theta is equal to y over x, we also have that tangent theta is equal to sine theta over cosine theta. Why is that? Well, sine theta is y over r. Cosine theta is x over r. So the r's cancel actually, and we're left with just y over x. So we get the same thing back. There's no difference. Alright, so pause and practice this last one on your own. You're going to have to use a Pythagorean identity and the identity for tangent that I just mentioned. Alright, so if we know that cosine theta is negative square root of 3 over 4 and sine theta is greater than 0, notice the signs of these things right here. Sine theta is bigger than 0, which means that the y value is positive, so we're looking at either quadrant 2 or quadrant 1. And cosine theta is negative, which means the x value is negative, This is the y value, that's the x value. X value is negative, means we're on the second quadrant. So there's the triangle we're working with. Cosine theta is negative square root of 3 over 4. And we need to find the value for sine theta and tangent theta. Right, we know how to do this using the Pythagorean theorem. We're going to find this using the Pythagorean identity. So we know that sine theta squared plus cosine theta squared is equal to 1. Since we're trying to find sine theta, we're going to subtract cosine theta to the other side. 1 minus cosine theta squared. To find sine theta here, we're going to take the square root. And sine theta has to be positive, so we're just going to use plus square root of 1 minus cosine theta squared. Which is 1 minus cosine theta is the square root of 3 over 4. So the square root of 3 over 4 squared. This is 1 minus the square root of 3 is 3. 4 squared is 16. So instead of writing 1 here, I can write 16 over 16 minus 3 over 16. Or, what's 16 minus 3? 13 over the square root of 16. Which is the square root of 13 over 4. Now that I know what sine is, I can just write tangent is sine square root of 13 over 4 over cosine. Cosine is negative square root of 3 over 4. The 4's cancel, I'm left with the square root of 13, which is negative, over the square root of 3. And one last step, I'm going to rationalize. I'm going to multiply by the square root of 3 in the bottom to give me 3. I'm going to multiply by the square root of 3 in the top to give me 39. And the minus sign is still there. You should now be ready to start homework section 6.2.